live. I also think I don't have chat set up yet, but I definitely can. So let's do that. Let's set up chat. Trying to remember how I did this. Yeah, try that, try that. Okay, I think chat is working now. Also make sure we're using the right microphone here. Yep, looks like it. Might echo a bit for a second. I'm checking my own audio. Also make sure we're using the right microphone here. Yep, looks like it. Might echo a bit for a second. Checking my own audio. Okay, that's probably better for the mic, although you are going to hear my mouse clicking a lot. So, sorry about that for anybody that gets annoyed by annoying mouse clicks. Which is how it's got to be. Okay, that's probably better for the mic, although you are going to hear my mouse clicking a lot. So, alright, cool. Sorry about that. And speech chat is up, so if anybody wants to join in the chat, you are free to do so now. And I will update the links for the people that wanted to see this on stream. Here is the new link. And then my post here. Here's the new link. And then on my personal okay, that ought to do it. Okay. Oh, so the thing covering half my screen. Alright, so we are going to do a bit of CAD work now that we're inside the house. What you guys can't see is just off screen. Hang on, I gotta be able to see my own camera in real time here. What you guys can't see is just off screen I have my kitty. Say. Salem. Hey. Where you doing, kitty? I have the heater on here. She loves the heater. So, oh, there's the purse. That's a good kitty. Oh yeah, look at the camera. So yep, we got Salem in here hanging out with us, along with all of you lovely people watching this on YouTube. Keep my face down here in the corner. We'll go back to the actual part here. So there is my intake design. This is what we'll be editing today. We are looking to fit in our fancy dual sensor map and IAT sensor, which is over here. So this is what we were talking about in the garage earlier. There is our sensor. This is a Bosch all-in-one manifold pressure and intake air temp sensor. It simply requires a hole to be inserted into and then a spot for us to secure it with a bolt, and that'll go inside this intake design somewhere. For those who missed the stream in the garage, we were talking about the intake design. So here is the printed version. Switch back to my self-view screen here.
John Galloway said, "Nice."
Thank you, and welcome, John. So there are already holes. So there's the intake manifold printed. So that's what you're seeing on screen. You're seeing a 3D model of this. And then in my hand here, I have a 3D printed version of that same thing with our throttle body attached to it. On the back side, we have some ports available for vacuum reference. So that is the thicker one that you run back to the... Sorry, I'm mirrored here. That's the thicker one that you run over to your brake booster. A small one for standard vacuum line for things like vacuum reference for the ECU or for the fuel pressure regulator. And then on the mirrored side, 3 more smaller ones for any other vacuum accessories you might need to add, like the factory distributor, vacuum for people still running the factory distributor, extra vacuum reference for any accessories that are vacuum driven, stuff like that. There are other things you might need vacuum for. I thought, let's plan ahead and put in more ports we need. So if we go to the model, I will open it up for you guys. And you can see there are those ports that we were talking about. So there's the big one of the small ones. You can see I've made this spot extra thick compared to the standard part. That way we could fully insert a vacuum port and not risk cracking it or having too thin of a wall. I made the walls nice and thick in those spots. So basically what we want to do is probably move these components over or duplicate this whole thing on this side. That way we can still have our big vacuum port for our brake booster. Instead, make this block a tick higher and let this be the one for the sensor. Or make it a bit thinner and make sure the sensor actually fits through the hole. Because looking at the sensor on camera over here, you can see that it actually doesn't protrude in a whole lot. So if our design is too thick, this actually won't fit in the airstream enough to work. So with that in mind, we'll have to just kind of play around with this. So step one, we have to measure and kind of half model this so we know where it fits on the design. And then we have to edit our design so that this fits in place. That way I can have that done now before this goes to get machined out of a solid block of aluminum, as is the goal. So I'll set that off to the side for now. I guess step one, we need to measure some things. So I will get out our handy dandy calipers. Ooh, where are they? They're not in their case. Where they should be. Ah, there they are. I got them out. Alright, so step one, how big does our hole need to be for this device? It needs to be a 12 millimeter hole. How deep can we sense? So I'm just going to measure how deep that is before we actually really need to be, before it's considerably too thick. I'd call it right about there. So really about 11 millimeters, maybe 10. And how thick is this? From here to here, we're looking at this number down here on the bottom, 12. So how thick I have it now would be almost too much. Let's see, what does 12 look like exactly? So 12 gets us right to the edge of that intake part of the sensor. Right to those little openings is 12 to the base of this. So 12 might work. We might get away with that. Ideally, though, we'd want it to only go through that top portion. So let us roll back this parts tree here. Where is this drawing at? Vacuum fittings. Oh, look at me being so good labeling my stuff ahead of time. Really thinking ahead here. Trying to find, there it is. Alright, so we can roll back our design to that point. Yep, that looks about right. Face of sketch 14, you say? So that must be from these fillets. Oh, we can't see into it yet. So it looks like our fillet's already there, so that's fine. Alright, this sketch is not defined currently. Can I just delete this dot? Oh yeah, look at that. Sketch is now defined. Great. Okay, so I just copied those sketches over, it looks like. So let's do that again. We'll just edit this sketch. Oh, I hear it sailing. There's a bug in here. Looks like a Kentucky state bird, aka the stink bug. It must be in here because it's nice and warm. Alright, since we're in okay, let's just full screen this so we can see what we're doing. Since we're in Onshape, we can quickly convert this entire shape into a sketch. That should carry it over to the extrusion. Fantastic, look at that, there it is. And now we can fix all these edges. Want everything nice and smooth in here for our airflow. Nothing needs to be messy. Yeah, that looks pretty darn good. Ah, we lost the reference somewhere. No worries, we can copy that over. Looking for 10 mils from here to here. And really, so we want this sensor on the back of the intake. We want it facing that way. So let's think how deep we really need this to be. Alright, so we need to get our center distance for the mount holes for this, so that we know how far we can go up or down, where we did those weird extrusion looking doodads. And thankfully on this sensor, if I'm looking at this correctly, it has these two. Again, I think our camera is not great for you guys to see what exactly I'm doing. Maybe if I make myself bigger for a second in real life. So we have these two holes we're referencing. So there's the mount hole and the hole we need to drill for the sensor to actually go in. Do you want to focus here, camera? Camera? You want to pick this up? No? Okay, great. So there's this hole and there's the sensor itself. Now, the way Bosch has had this molded, there's actually a nice little crosshair showing the center of that hole. And if you look at this piece here, there's a crosshair showing us the center of that hole. So we can simply measure across those two crosshairs and know our bolt distance, which is great news. Makes my life much easier that way. 20 millimeters. I love a good whole number. So let's take our vacuum holes drawing. Let's delete these measurements. And let's try to stick these on the other hole over here. Because this has wires going to it, and I want the wires to be on the very edge so we can wrap them however we see fit, and then not get in the way of the other hoses. Oh, the cat's grabbing my thing. Oh, sorry, I forgot to move my camera back. Yoink. Alright, so we just move these over. How far, I'm not sure yet. Same deal, we want to go for about here. That one was 10, and I believe this other one was 8 from the edge. Yep, 8. Now for this guy, the flat part rests all the way up. So we need a 12 millimeter hole. Over here. And then 20 millimeters above that, we're just going to put a small hole for now, because we actually need to go through and make this a drilled hole here in a minute. But we already know that those have to be, first of all, vertical from each other. And second of all, they have to be 20 millimeters apart, center to center. Let's do a section. Well, not really a section view. We'll just keep working like this. So I think we want to probably bring this whole face up so our bolt goes through a thick portion. And we'll probably end up chamfering this hole just to allow it to fully sense on all sides. And we said that from here to here was 12, from edge to edge was 12 millimeters, and that just worked for this, so that should be plenty fine. Alright, so let's take that center line. Let's say it's going to be we'll call it centered. So we'll take that off. We will make that centered with this line. Let's say 25 millimeters from the edge. No, let's go 20. Go back to that for a second. How far is this dot from this edge? In the X direction, it is 35 millimeters. So I want to know that distance, because if we have this in the back of it, and we know that from here over is 35 millimeters, my question is, can you see the tip of my connector hanging off the edge of this assembly? I'd like this to be hidden. I'm trying to make all my wiring as hidden as I can make it. So if that's hanging off the side, that would be not ideal. It may actually be better in our case to make the connector face the inside. Our vacuum lines come off the edge like they were, straight back. The connector comes off the inside and goes towards the middle of the intake, where we actually have a hook to do wire management. So let's do that instead. Let's go back in here. We'll unmeasure this. Vacuum hole sketch. Make this one 12. This one 2. Make it so it's not stuck to that edge. Oh, I like that a lot more. Alright, let's do that. So now from here, let's bring it up. $4 mil. Let's see what this would look like. This is going to be an M6 bolt, so it's going to be a 5mm hole. Make sure we have plenty of thread depth there, and we do. Let's bring that back to 2 for now. Now with our sensor on the back side of that, facing the connector in, there's really nothing stopping us from any direction left or right, so might as well just center it. And then this guy we had at 8, and from here we had it at 10. That's pretty good. Alright, so now this is where our sensor will live. We still have our vacuum fittings. The sensor has more room to read than it did previously, which is great. Let us bring it back to the full part. There we go. There's all of our fillets. Can we fillet this line? Oh, we can? Well, that's just fantastic news. Let's do that. Let's make this intake as smooth as we can get it inside. And then we can use our hole tool. Let's see that sketch again. On this hole, we need a drilled, we need a tapped hole. Straight tap is fine. Metric. Tapped. M6 by 1. Normal fit. Or we can say none. That's fine. So now we have specified that that's an M6 drilled and tapped hole. And then we can turn off our sketch view. Okay, so let's think this through real quick. We've got our extra vacuum fittings. We've got one for our fuel rail, which sneaks down to here. One for the brake booster, which goes straight back. Then our sensor will sit here, the plug facing left. Now I'm looking at it now. That means the top of this will be above our part center line, which should not matter. The connector face is off the edge, so that should be totally fine. And then our wire can come out from the edge of that, down, and right about here in space, right about here, there is a hook for all the harness for the injector rail and stuff. There's a spot to cable manage those wires, so we can drop that straight down, manage it here, it'll branch to the left and join up with our loom for our injectors about here, which would be totally fine. I can share the branch for the drive-by-wire even. Yeah, I like that a good bit. Put our top back on. The only question then is this too close to the edge for comfort? Because we are also, well, one side gets the relief. The top side, yeah, top side gets the O-ring relief, so that might be alright. You know what, we have the space to bring it down, so maybe we should just bring it down a bit. I was worried about it hitting, like, the sensor, like, fouling on this stuff, but it'll read pressure just fine. Let's bring it down. So I wonder what's changing to make it look higher now than it was. Oh, I see what I'm looking at. So this hole is drawn based on this face. If I turn it some, you can see it's actually floating in the air here. So I was kind of confusing myself having it at this angle. It's actually floating away from that surface, so it's not that close to this edge like it looks like. That makes way more sense. I should have been looking at it from the back. Okay. No, that looks great. Except I tapped that one hole all the way through. That would have been bad. That should be at least 15 millimeters. It's just past the thickness of the part. Alright. So there you go. There was some CAD work, and now we've got a very nice looking part with room for our fancy new sensor. So let's go back. Then leave this as is. That's basically ready for machining now as far as I'm concerned. And let's fix our cam sensor bracket. So this is the one we also checked outside earlier. Oh, hi kitty. Yeah, kitty kitty. She just curled up in a little ball. She's taking a big nap. Big cat nap. Alright, so here was our sensor bracket that we were messing with in the garage as well. And again, it probably won't focus correctly, but our O-ring is not sitting in our channel. Our channel is way too thin for the factory O-ring size. I absolutely mismeasured that channel size. It needs to be way deeper. By way deeper, the exact depth, I mean, would be the width of our O-ring in this case, plus a tick. So this O-ring is 3.5 mil, and I think my channel is 1.5. Yeah, that's way wrong. Okay, that needs to be like probably 3.6. This needs to be like 3.8. Maybe even 4. .2. No, we'll call it 4. Let's leave 1.5. No. We'll probably measure a factory distributor just to see how deep they're running that O-ring normally. Before I get too crazy. Let's also make sure we're not cutting too deep. Let's make this transparent for a second. Let's highlight this edge. Okay, that part gets way thin. We're gonna need to thicken that up. Otherwise, like, yeah, that's how thin it is right here. That's not gonna cut it. More like that's gonna get cut. Still a little thin. That's better. Alright, turn back normal view. Probably print one of these just for another test print, test confirmation, fitment confirmation, whatever the words are. All right, let's check our printer. So we need to start heating up the printer. So the chamber is set for ABS. Here's our last test print. We will want to basically run those same settings again for the new one.
John Galloway said, "Man, this is way above my pay grade. Anyone else feel like they're in college or a tech school watching the professor at work?"
I'm not that good, brother. Once you do it a couple times, it gets a lot easier. I was modeling stuff like this well before I had professional training on the matter, and now that I had professional training, I only kind of wish I had more, so I could do more complex and organic shapes and less parametric, like very technical solid shapes like this. Cam Sensor bracket new. Go ahead and upload that. Check on the printer here. I'll zoom in so you guys can see. So there's our temperature. Right now we're just heating the bed. And when the bed starts getting hot, that will heat up the entire chamber for the printer because it's like a 1200 watt heated bed. Once the whole printer's hot, ABS will stick properly, and then we can tell it to go ahead and print. And there's the new one. So whenever we're ready, we can just click on that. It will show us a new picture, and it will start printing that. All right. Was there anything else we need to do while we're in here? I don't think so. Oh, we did need to format the SD card and set the clock on the ECU, actually, because we did install the new battery so that it would have a clock. Dude, this cat is passed out right now. Let's go back to cat cam for a second. Don't tell her I showed you guys this, but oh my god, look at that. Look at this big thick kitty sleeping. Hang on. Cat cam. Look at that sleepy kitty. Salem. Kitty. There she is. Hi, kitty. We'll give her some pets. Oh, hi. Yeah, we'll give her some pets. She used to not be very cuddly. And then she's getting a bit older. She's either 2 or 3 now. I can't remember which November it was I got her. But she used to be a very demon, bitey, evil cat. And then as she grows up, she's chilling out a little bit, getting a little more cuddly. And we sadly lost our other kitty. She was, I think, 14 years old. Had her, my wife got her right before we started dating, so she's been with us together like over 13 years. And she passed away rather unexpectedly about 2 months ago. And I think since then, with no other kitties to play with, Salem's gotten a little more cuddly, a little more chill. It's been very good. Alright, fix that back to where it was. And I will find the right cable for our ECU, and we will do some ECU adjustments real quick. Because that's stuff we gotta do on the computer, and we are here at the computer and not out in the freezing ass garage. So, hold on, little kitty, we're backing up. I gotta steal this USB cable because it's the only one I have that seems to work correctly right now. I was charging my phone with it earlier. Alright, coming back. Just hold on, little kitty. Oh, she's doing so good right now. Oh, I ran over something. It's making a lot of sounds. She's chasing it. What was it, Say? What did I drop? A tiny screw. Wow. Alright, you come back now. Come here. Well, now that we woke her up, she might not stick around. She's purring, though. She's absolutely chock full of purrs tonight. Alright, so we will plug in the ECU again. Boop. There we go. There we see. We got some lights. We got Bebop from Windows. This has a slot for an SD card. It's all based on the Teensy 4.1, which is a modern, very powerful yet very small microprocessor. This is actually, like by definition, this is like the fastest aftermarket ECU on the market because this thing runs at such an insane speed. Yeah, I know, kitty. Alright, so we have our battery in. I've put the SD card in. Let's get it set up while we're in here. By in here, I mean in the office and not the garage. Hey, kitty. Where you going? Where you going? Oh, God. Oh, God. Help me. Hang on. I gotta get the camera back over here. So she stood up and started staring at me. And that is because there is the bird. The state bird. It's on my shoulder right now. Sorry. Look at that. It landed on me. I didn't even notice, but she did. Oh, God. Salem, help me. It's getting me. Don't let it get away. Salem. Help. Help me. Kitty, right there. Get it. Get it. Oh, fat lot of good you are. Oh, yeah. Yeah, Salem. Salem, help. Salem. Salem. Kitty, look. It's on the back. It's on my back. There he is. I'm just gonna put him in the trash can. If he makes it back out of the trash can, then I guess that's his prerogative, huh? Oh, now Salem's on the table. Back up, kitty. More. Here, why don't you have that chair? Whole chair all to yourself. Then we'll go back. Try to see what the heck we're doing. Alright. There she is, Cat Cam. Here we are, we're in Tuner Studio. Let's open up our last project. We are connected. Alright, then we need set up the clock on board, set the time, burn it. Fantastic. Then we set up the SD card, full speed. And then we boop. We just need it to log on boot. Yep, just keep logging for as long as you want. Start logging as soon as we get above 600 RPM. Turn it off as soon as we're below 400 RPM. Alright, we have officially set up, or wait, did we? Let's make sure it's formatted, I suppose. Salem, did you just find that same screw again? You're such a turd. Okay, I think that's it. I think our ECU is now set up to log correctly. There's not a whole lot of other stuff we can test on the ECU currently, sadly, because we don't have sensors like available right now. As in, I don't have a way to plug in a temp sensor or plug in our map sensor, for instance. Theoretically, we could test this by plugging it into the ECU and then reading some of these values, but I cannot currently. But this is where we'll be tuning later. You see we have like our spark tables here and our fuel tables. We also be doing flex fuel. It's hard to see because my screen is really dense. 1440p screens do not work great with Tuner Studio, but so there's our current map. This is not really adjusted for anything. This is just a default map loaded in. I think this is a Miata map. I think I already put in a Miata 1.6 map, which is great. It's a great start for us to get our timing and stuff locked in. Well, it will need a lot of adjustments for us to get it where we want it to be. All right. That was actually a lot faster than I expected. Our stream's only been how long now? 45 minutes? That was fast. So, yeah, that's actually all I wanted to do. It's going to take longer for the printer to heat up than anything. As you can see, it's only 34 degrees in there right now, and we would like it to be closer to 60. So with that being said, is there anything else you guys in chat want to see as far as this project goes, like our intake project or ECU project? Because I can talk all night about how this custom ECU thing is going to work and all the sweet sensor stuff we're going to do and the wiring harness we've been working on for anybody interested in that sort of thing. But we have fixed the thing we set out to fix, which is excellent news. Clean up my desk a little bit. At some point, I'll probably get a camera actually set up inside the printer so that on live stream we can see it printing. I think it's something that somebody suggested before, and I think it would be really cool to actually see the printer in action. But I think that does it for now. All that's left for me to do is to talk to some suppliers about some of the parts we mentioned on stream the other day, or earlier today, and prepare for tomorrow's shenanigans. So, as always, thank you guys so much for joining me. Tomorrow, if you come around tomorrow evening and most of Sunday, we should actually be doing some real work on the car. Steve and I will be getting down and at it, doing probably the core support mod, some engine bay cleanup, all sorts of fun stuff. So I hope to see you guys there for that. So yeah, catch you guys.